All right, next set. Hopefully we can agree that the right side is definitely going to be a little more complicated. So I'm going to leave the left side as is. And remember, we've got 3 options for rewriting cosine of 2 theta. I'm trying to keep in mind what my left side looks like. And on the left side, I just have secant, which I know is the reciprocal of cosine. So my thinking is I kind of want to keep the right side just using cosine as well. So when I think about my 3 options, I'm going to pick the option that uses cosine. So to replace this, I'm going to use, so it'll be 1 plus, I'm going to use the 2 cosine squared minus 1. All right, now we just need to do a little bit of simplifying. So we have 2 over, all right, now 1 minus 1 is 0. Okay, so 2 over 2 cosine squared of theta. Do you guys see the giant 1? I hope so. So now I have secant squared equals 1 over cosine squared. And then hopefully you recognize that right away here you can use your reciprocal identities to rewrite 1 over cosine squared as secant squared. All right, next up. So we have cosine of 2x on the left. We know there's 3 options there. Doesn't really help us a lot because we have no idea which one to choose, and none of the 3 options has tangent in them. So that would definitely make our lives a little bit tougher. But on the right side, I do notice the potential for Pythagorean identities. So what I'm going to look at is that 1 plus tangent squared, that's definitely a Pythagorean identity. That I know I can change. So I'm going to start with that. So I have 1 minus tangent squared in the numerator, and then in the denominator, 1 plus tangent squared is just secant squared. Now, the nice thing about that, there's a couple things you could do with that. So you could, change everything to sines and cosines, multiply by the reciprocal of your bottom fraction, or remember this idea of splitting up your fraction. So you could split up the fraction so you have 2 fractions here, okay? So what I could do is change, get my pen back here, is change that 1 minus tangent squared over secant squared into 1 minus secant, or 1 over secant squared minus, and then tangent squared over secant squared. Okay, well, let's go ahead and see what we can do with that. So cosine of 2x isn't changing. On the right-hand side, I noticed 1 over secant squared. That's cosine squared. That's good news. Okay, minus. I probably am going to go ahead and rewrite everything in that second fraction in terms of sine and cosine. So tangent, using my quotient identities, would be sine squared over cosine squared, and then secant we know is 1 over cosine squared. Now, some of you might be able to do this in a little bit of a faster, less steps type thing, but I'm just making sure, with these videos that they actually help you see what you can do here. Then we can take our fraction over fraction, rewrite it as a multiplication, flipping the second fraction, and there's our giant 1. That's lovely. So now what I have is cosine of 2x equals cosine squared of x minus sine squared of x. And this is when I could then look at my double angle identities and realize that I have it written here. All I have to do is change the right side to be cosine of 2x. That is one of your options for cosine of 2x. All right, next up. This one is a lot like 10, so if you watch the video for 10, this will be very similar. But what I said in 10 is that this is actually a difference of squares, and I explained it a little bit more in that video, so if you wanted to go back and watch that, you can. But I'm going to go ahead and factor this. Cosine squared minus sine squared times cosine squared plus sine squared equals cosine of 2x. Now, the reason, again, I chose the left side over the right side is that cosine of 2x has a lot of possibilities. Okay, right off the bat, and guys, this should be something that you recognize right away. Cosine squared plus sine squared, that's just 1. So what I have here is cosine squared minus sine squared times 1. And then just like in the previous identity, This cosine squared minus sine squared is in fact cosine of 2x. It's one of our 3 options. So we can go ahead and use that substitution. All right, last but not least. This one you had to use your sum and difference formulas. I'm not going to write them on here because you have them on your formula sheet, but you're going to use the sum and difference formula for sine of x plus y. So that's going to be this guy here, sine of x cosine of y plus cosine of x sine of y. And then we're going to multiply that by sine of x minus y. So that's sine of x cosine of y minus cosine of x sine of y. Now, because I'm going to run out of room here, I'm just going to say, hey, just that gets brought down here. I just don't have room to write it. Okay, once again, we spent so much time at the beginning of the year focusing on factoring because it's important that you notice this is a difference of squares. So to multiply it out is going to be super quick. We just have to multiply these first terms together, which will give us sine squared x cosine squared y minus multiply the second terms together, cosine squared x sine squared y. All right, what are we trying to get? Sine squared x cosine squared y minus sine squared y cosine squared x. And I hope you realize that it is actually the same thing, right? This and this are the same. And then we just have cosine written first here. All we would have to do is rearrange the order that those are written. But we do have the same thing. So we got it. That one was a lot quicker than it looked like it was going to be.